All right, this is our first interview for our first grant, where we have to wrap up what we learned this year. And specifically, you two guys worked a lot on the starting of the program of the robot. Tell me what you learned about using LabVIEW and what we think we're going to do next year.
What I learned about LabVIEW is it works as, it's sort of like block code, but it works as a wiring type system where you have to connect, when you write a program, you have to connect each part to the different programs you want to do.
And I learned that LabVIEW, while it is more difficult, there's more flexibility with it than C++. While it would have been easier to do C++, LabVIEW would have offered way more options in terms of controlling and setting up the actual robot.
What were some of the difficulties, though, of using LabVIEW?
Basically figuring out how it worked, because they said it was a block code, and obviously block code is just like drag and click. Oh, that's easy. Block code is simple. It's like what you teach the kindergartners, middle schoolers, basically how to code. LabVIEW is completely different. While it is in block form, it is essentially nothing like block coding.
The challenging part of LabVIEW was that, just like what Craig said about the block system, and the thing about it is you'll make a block, but you have to actually type written code in that same block, and then you have to connect it to another block to make that whole code work.
You think we'll use it next year, or should we go at a different approach?
We should do C++ next year.
Yeah.
Why?
Well, it is easier. I think it's probably going to be... I think we should use C++ for certain parts and aspects of the robot, rather than just all C++ and all LabVIEW, because LabVIEW does have greater flexibility than C++.
I would argue go at everything C++ because everybody knows C. Most of the robotics team knows C++, so it's easier, and we could just write more code to do a task. And like I said, the robotics team knows C++, so it's more flexible, that everybody will understand, instead of one person will understand LabVIEW and the rest of the team won't.
It was a great experience going to the robotics tournament. It's very different from VEX. First is a lot more friendly.
All right, here we got Joe and Heather, who acted as the senior leadership, the team captains of this year's program, and they were mostly responsible for the build of the robot itself. What can you guys tell us that we learned building this particular robot?
First, we learned about the first makeup of the robot. Then through collaboration, we start to learn how to get the motors working, the engines, and the lift was a little problematic at first, but we slowly learned how to go around that.
Heather, in your first year trying this kind of stuff, how did you find it different than other academics that you've done at Central?
Well, this was more of a huge team effort, and everybody had their specific role in making the robot. So based on this compared to other like extracurricular things I've done, it's more of like a really good team building type thing, because everybody has their role and everybody has their specific niche that they like.
Joe, from a standpoint of difference, we do VEX robots also. How is this different than the VEX? Joe, tell me about the motor situation. I know with VEX, you just kind of plug the VEX motors in and they work.
Yeah.
What was really different about these particular motors, and talk about the variety of ones that we had to deal with and those gearboxes? Because you messed a lot with the gearboxes.
Well, from VEX robotics, you just basically get the motor, then it's attached to the robot. But with these gearboxes, you learn how to the actual inner workings of the actual motor, and learn how to construct together your own motor from the pieces of the gear.
What did we learn about the gear ratios, especially? How did we mess up earlier in the year?
Earlier in the year, we went for more. We messed up with the gear ratios because with VEX robotics, the motors are already fast, so we usually change it to more torque. But since this is a new first robotic, we thought we'd go with the same plan and have more torque. But that completely messed up. When we completely messed up what we tried for, what we wanted to, instead of what we got. So that way we learned how to configure the gear ratio for more speed and strength, instead of just full out torque. It's on a much bigger scale. And through first robotics, we usually deal with small aluminum and small engines. But with this first robotics, with the big motors, engines, we have to wrap our hands around the speed of those. Plus, we have a whole lot of new pieces that we didn't know how to fix and configure into making our new first robot.
As seniors, you were both kind of responsible when we were down in Knoxville for keeping the team together and keeping them focused. What kind of advice can you give to next year's captains?
Just keep your head in the game, but also have fun, because I had a really good time.
What was the best part?
When we climbed up on that third level using the ramp robot.
Oh, yeah. We were able to get the taller platform with assistance from somebody else. All right, well, thank you guys very much. Hey, now we got Rue and Kristen here, and we're going to ask them to talk about the experience of the tournament itself and some strategies we're going to have going in next year.
So for VEX tournaments, we've noticed that in VEX tournaments, people are focused on winning. That's the main goal, winning and defeating everybody else. Teamwork only matters to an extent of one match or getting lines. But with first, it's there's more spirit in it. People are more happy to be there. They want to be there. They want to show off. Or they want to create things to show off.
We feel like it's much more important to have alliances in first, as you really need those to advance in the competition, whereas in VEX, it's just about getting first place, second place, third place.
What about from a standpoint of we took a minimal amount of equipment this year? What do we need to take next year or to our next tournament? How can we be better prepared for that tournament?
A better stand for the robot would be first thing. Maybe a couple of projects that were made, because we realized many teams brought in their own projects, like software, games, or just cool things they made.
Because it's about having a good presentation to attract alliances.
Go back to that stand. What happened with their stand?
It's pretty small.
Non-existent, kind of.
It's very difficult to put the robot on it. Also, it was very tall. So, like, if the robot were to fall off, it would fall off from a pretty tall height.
From a standpoint of planning, what is next year going to look like then? What do you think we should do in the fall? Then what should we do in the spring?
Near the end of our competition, maybe, or in the beginning, we should start with forming teams. One team does this, and one team is focused on this. Because this year it was kind of scattered. Like, half the kids would just be switching back and forth.
I feel like having individual groups of people who are specialized in either coding or building or designing certain parts of the pieces would allow us to not have to spread ourselves thin or have people who are confused about certain elements. We could have certain groups that are like specialized in a certain topic.
So everybody's best is doing what they do best.
And everyone has something to do.
All right. Well, thanks, guys. Here's looking to next year. All right. Here we have Zane, who was in charge of helping build the arm. And Zane, tell us what you learned about building this robotic arm. How is it different than other things that you've done?
Well, normally in VEX, our VEX bots, our lifting system is completely different, and also everything was a bit bigger and a bit harder to put together.
You were good about putting the screws in and tighten them down and put these nuts into these little channels. How did you devise a system to do that?
So the screwdrivers we use for the VEX robots are a little magnetic, so I use that as kind of to get them in the right position, so I could get the nuts in the right position so I can screw them in there.
Okay, and then so you used kind of a VEX screwdriver to hold the nut in on the first robot, right?
Yeah.
Which is the confusing part. And then you were able to hold them steady and put the arm together. How did you think the arm did in the competition?
Honestly speaking, not too great.
What could we have done better?
I think next year, and we could have done better is we could have used pneumatics. It's generally could have worked better.
So, how are we going to learn about pneumatics? So,
We're gonna set up some during the off season between now and next. We're gonna set up some next year's bursts. We're gonna set up boards to work on how to do the pneumatic stuff.
all right, let's go to the competition itself. What did you learn this year about the way first competitions work, and how can we have a better strategy whenever we go to one next year about talking to other teams and so forth?
So normally during VEX, you normally just you don't really work with other robots that much. You show up, you talk about what your robot can do, and that's it. But when you're talking with VEX teams, you're able to talk about also what your robot can do, and also about like your strategy about working together in the competition.
You mean talking with first teams, right?
Yeah.
Yeah. So the first experience was considerably different than the VEX experience, and so next year we got to learn how to basically approach the other teams and learn how to ask for more help, right?
Yeah.
All right. Okay. Thank you, sir.